So here's a problem about wholes, rational functions, rational expressions, and it says which of the following has a 0 at x equals 3 and has a graph in the xy plane with a vertical asymptote at x equals 0 and a hole at x equals 1. So the first thing I always do when I see expressions like this is factor them. So I can factor this top one, let's see, so that's going to be x minus 3, x minus 1. Over x minus 2, x minus 1. I'll come back and deal with reducing it. At the top, I have x minus 2, x minus 3. Over x minus 2, x minus 1. Looks like we've got a bunch of x minus 2, x minus 1 in the denominator. That's good, except for the last one. For the third one, I don't have anything to factor at the top. There's no common factor, and it's linear. But in the denominator, I can still get x minus 2, x minus 1. And similarly, I don't have anything to factor in the numerator of choice D. But the denominator now, I get x minus 3, x minus 1. Okay. So now let's figure out what happens with these. I need a 0 at x equals 3. So this right here means that I need an x minus 3 in the numerator after reducing. I can see that when I reduce this one down, I still have an x minus 3 in the numerator, so that will have a 0 at x equals 3. When I reduce this one down, I still have an x minus 3 in the numerator. When I reduce this one, it doesn't reduce. I still have an x minus 3 in the numerator. But this one, when I reduce it down, does not have an x minus 3 in the numerator, so that does not have a 0 at x equals 3. Let's keep on going. So I need a vertical asymptote at x equals 2. So vertical asymptote at x equals 2. Let me change colors. That means that I need an x minus 2 in the denominator after reducing, and I can see that, let's see, choice A has an x minus 2 in the denominator, choice C has x minus 2 in the denominator. However, the x minus 2's canceled here, so this will actually have a hole at x equals 2, not a vertical asymptote. And let's finish it off with a little bit of finding a hole at x equals 1. So that means that in canceling, so while canceling, I need x minus 1 and x minus 1 to cancel, and I need to have no more x minus 1 in the denominator after that. I see that I still have an x minus 1 in the denominator for C. That means I have an asymptote, a vertical asymptote at x equals 1 for that, whereas the x minus 1's cancel in choice A, so our answer is A.